Hi, everyone. I'm Mandy, and today I'm going to be talking about the machine learning platform at Wealthsimple and how we leverage it to deploy a model in under 15 minutes. From powering money movement to fraud detection, machine learning is critical to several core business processes at Wealthsimple. However, it used to take us just months to get from a trained model into production, and this made it very challenging to keep up with the constantly evolving business ecosystem. What we needed was a platform, a way to simplify our architecture and reduce the need for duplicate efforts. Only by abstracting the various complexities around model deployment were we able to empower data scientists and model developers to do their best work. A large source of inspiration for this platform came from Ruby on Rails and how it transformed the web development landscape in the early 2000s. In 2005, the creator of Rails, David Hansen, demonstrated how to build a blog engine in just 15 minutes. This was completely unheard of at that time, as something similar would take weeks or longer to do. We wanted to have that same eureka moment for productionizing machine learning models. How cool would it be if we could deploy a machine learning model in just under 15 minutes as well? The 15 minutes part is a bit tongue-in-cheek. It's 15 minutes for a toy model, within hours for a production model. This became the basis and underlying requirement of our entire ML platform, getting from trained model to prediction serving within hours. We had a few guiding principles in terms of choosing architectural decisions, and these were largely inspired as well by the Rails doctrine. They were to favor convention over configuration and to put the developer experience on a pedestal. This is a simplified ERD of what our ML platform looks like today. We built the first version in just under 3 months. If we were to start from the right-hand side, the developer interface for model training is a REST API over an MLflow backend. We host each model as a separate MLflow project within this application. The goal is to create a containerized environment to develop and train each model in isolation. That way, developers can choose the most suitable frameworks without worrying about conflicts. The first models on the platform spent a lot of time mulling over configuration, whereas subsequent platform improvements favored convention. Each model comes pre-generated with a bunch of boilerplate code that provides MLflow integration, deployment plugins, and common scaffolding such as error tracking out of the box. This is a snapshot of what it looks like today, and this became a stepwise improvement in how quickly we could ship new models. Over 60% of this code makes its way into production. This code also includes utility for converting between frameworks supported for model development, such as scikit-learn and TensorFlow, into frameworks supported by our prediction serving services, such as Onyx and the save model format for TensorFlow. With one single integrated system to manage the entire machine learning lifecycle, we were able to streamline the actual deployment step into just one post request. This request did two things. The first is to track the model within the model registry, and the second is to copy the model assets to our S3 model store. We actually further streamlined this with Airflow, our orchestration system. In literally just the few lines of code you see on the screen, we can set up a system for continuous retraining, continuous improvement to close the feedback loop. That's the custom operator we had written. When it comes to prediction serving, we use the open source framework provided by NVIDIA called Triton Inference Server to do prediction serving. The contract between Triton and the rest of our platform is through the S3 model store. Every few seconds, Triton will pull the S3 model store to see if there's a new candidate model for serving. And if you look just below Triton on the screen, we have another service built on top of that called Prediction Hotline Service. This is our gateway between the ML platform and doing predictions with the rest of our services. The consuming services would pass inputs to Prediction Hotline Service and receive predictions in return. This service not only provides a pre-processing and post-processing layer on top of Triton, but we also inject core functionalities such as A/B testing and enabling shadow scoring mode here. So a quick recap on how we can deploy a model in 15 minutes or within hours. So after a model has been developed, evaluated, and approved, it's a single API call to deploy the model, to get the model registered within the registry, and to move the assets to the model store. On top of that, we have the option to write any pre-processing or post-processing steps as well. So there's a lot of learnings from this platform. We learned the importance of creating an integrated system and to focus on the developer experience. There's also a lot of takeaways around finding the right balance between simplifying and also abstracting too early. So thank you for listening to my talk. I'd like to extend a thanks as well to the team at Wealthsimple, whose collaboration on the work I get to share today.